Hey everybody, here is a vector problem example, just that way in case you need some extra help kind of figuring out how all this works. So here's the example. An airplane's velocity with respect to the air is 400 miles per hour and is heading north 45 degrees west. The wind at the altitude of the plane is going to the southwest and has a velocity of 20 miles per hour. Draw a figure that gives a visual representation of the problem. What is the true direction of the plane, and what is its speed with respect to the ground? So if you're on the ground looking up, the plane thinks that it's going 400 miles an hour no matter what the wind does, but if you're on the ground, you'd say, oh, well, something's going to happen and they are going to slow down or speed up, something like that. So on the ground, you can be able to tell what is the speed, okay? So the ground is kind of like the resultant. It's going to be what happens at the end. All right, so we have two vectors we need to know about. We have the plane vector, and we're going to have the wind vector. All right, I'm going to do each one of those on a separate graph, okay, or on a separate slide, because it's going to be kind of hard to see. Otherwise, I can't get all of it on here. There's too much for me to kind of keep it clear. Okay, so just if you remember, we're going to just draw this real small over here to say we know a plane is going north 45 degrees west. So we're looking at north 45 degrees west. If we say north, south, east, west, we know the plane is going this way, right? And the wind is going southwest. So sometimes what happens with southwest is that there's no number in between here. So maybe I should back up a second and just explain this. North, 45 degrees west. So that means we're starting pointing north, and then it's going to go 45 degrees this direction, right? 45 degrees that way. So that's what that means. Start facing north and go 45 degrees west. If there's no number in between here, it just says southwest, we can assume it's halfway between south and halfway between west. So that means it's going, and since it's going to the southwest, the wind would be going down this way. Okay, and this also is going to be 45 degrees for both of them. Okay, so that's the idea with this bearing. Don't worry too much about bearing, but that is the start of what we need to do. So what we're going to do is we're going to redraw that plane. And so we know the plane is going, I'm just going to do just the plane vector going this way. We know it's going 400. And we know this angle is 45. But if you remember, what we said was we want to have the angle with the x-axis. So that's 45 plus 90. All right, so we're going to use that whole angle to go from here to here. So even though this one's 45, this one is 90. Okay, so what we're going to do is, let's say that we have, if we want to find the x part of this, which means I'm just going to do this in red, the x part, the x component, we're going to say that to find x, and I'll do the y here in blue, right here. So we're to find the x component. Why did I use blue? I don't want to use blue. There we go, x component, that's better. So we're going to say x component. Now, even though we're going to use this angle right here, so we can do the exact same thing we did before, and we're going to be okay if we know the angle is going to be 135 degrees. So we can say cosine of 135 degrees equals the adjacent, which is our x, over 400. Now you might say, well, this angle is not really 135 degrees. We're talking about this angle, and it's outside the triangle. That is okay. It's actually fine to have it outside the triangle. We could say this is 45 degrees. So we could say cosine of 45 and make stuff positive and negative. But if we just use this cosine of 135, we'll get the numbers positive and negative that we need, and it will be the exact same as if we did 45. Just we get the negatives and positives out of it. So we can keep it just like this, and your calculator knows what to do with this. All right, so then in order to do this, we would multiply by 400, multiply by 400, and we multiply 400. We go to our calculator, and I'm going to make sure that I am in degrees here. I am. Another way to check is on the calculators. Look up here, see how it says degrees. Okay, so I have 400 cosine 135. So I can type in 400 cosine 135, and I get an answer. It's negative 282. Does that make sense? We can say negative 282 point whatever 84 equals x. Well, if we think of where we start as like the origin on the x and y axis, since I'm starting at the origin and going to the left, my x value should be a negative, so a negative answer is okay. Alright, so now let's find the y component. we're going to do the same thing. We're going to find, instead of cosine, we have the opposite of this angle, which is going to be right here. And since the 45 and the 135 are kind of complementary type angles, or I guess supplementary type angles, we're going to use the sine of 135 degrees equals y over 400. We're going to do the exact same thing, multiply by 400, multiply by 400, and if we think about this for a second, the y is going up from the origin, right? We're going over and then up, so I should get a positive number when I multiply these together. So let's see if, in fact, that is true. So we have 400 times sine of 135, and I get 282.42. This is good that I have the same number, because if it's 45 degrees, these two lengths should be the same. So that means it's positive 282. I think I wrote 288. Oops, 282.84. This should be a positive right here for the y. This should be a negative 282 right there. So now we found the components for the plane. So we're half done with our component parts. So now what we're going to do is let's find the component parts for the wind. Alright, so let's just draw the wind over here like we did. We know the wind is going southwest. So if we look at our graph, southwest, south and west is here. It's going southwest. It's exactly 45 degrees and 45 degrees there. And we know it's going 20 miles per hour. Alright, so if we want to find the angle that makes with the x, we could go this way or we could go this way. So I'm just going to make it the positive. Oops, I didn't want to do that. I'm going to make it positive, but we could make it negative if we want to, but I'm going to go that way. That's going to be 180 degrees, and this is 45 degrees. Well, what's 180 plus 45? It's going to be 225 degrees is going to be our angle. Okay, so now we can kind of get the idea for that one. Let's draw this here, and then we're going to do x component. We did x component was red. We'll keep it red. So the x component's this way, and the y component is going to be down this way. So I know my y is going to be negative, and I know the x is going to be negative because I went from the origin, I went left and down. So both of these numbers should be negative, right? And we know that what's the magnitude of our wind? How fast is it going? It's going 20 miles per hour, so that one is 20. All right, so to find the x component, so let's find the x component. That's going to be cosine, right? It's adjacent of our angle, even though we added more to it, the adjacent of this angle. So that's going to be cosine of our angle, which we said was 225, equals x over 20. So we're going to do the same thing, multiply by 20, and we get 20 times cosine 225 equals x. So let's type that into the calculator. 20, there we go, cosine 225. And if I hit enter, I get a negative number, and that's what I was hoping for, negative 14. So we have negative 14 point, I think it was 14, yep, equals x. And now let's do the same thing for the y component. Y component. So we're going to do the exact same thing. I'm actually going to skip this step right here to make it go a little bit faster. It should just be 20 sine 225 equals y, and let's just type that in the calculator. You can find that by doing the exact same thing we did up here. Alright, so 20 sine 225, and we said that was going to be a negative number. Since this is we said it was halfway between south and west, these numbers should be the same, and they're both negative, so that's good. Negative 14.14 equals y. Alright, so now what we need to do is we want to find the true speed with respect to the ground. So if you're on the ground, how fast is this plane actually going? So what we need to do is add our x's and add our y's. Alright, so let's add our x's. So we're going to add our x's at the plane. So let's do plane x, plane y. I'm just going to do those in red. Alright, I know I kind of did different colors, but we'll do the plane and x's and y's. So the plane is negative 282 and positive 282. So the plane x is, what was it, negative? Yeah. Okay. Negative 282.84. And the plane y was positive 282.84. Alright, and we're going to add that to the wind x and the wind y. Space that out so it doesn't look like windy. and that's negative 14 and positive. Both are negatives. Okay, so negative 14.14 and negative 14.14, and I am adding these together. So now I need to find what is the sum of these. What's the sum of these? That will give me the x component of the ground speed of the resultant. And this one will give me the y component. There we go. Component ENT. Sorry about my spelling. All right. So negative 282 minus 14. So if I take this, I can take this number. If I just hit enter, and I want to add it to this number, and if I get that through, I get negative 296.98. So I'm going to round that to negative 297. So that is negative 297 when I add these together. Okay, and now let's do the same thing with those. I'm just going to go back and hit, if I hit enter, I get all that stuff back, and I just want to go back to the beginning. So if I hit over a whole bunch of times, which is maybe not the most efficient way to do this, but if I go to here and I don't hit clear, just hit delete. And now if I hit enter, I've added those together, and I should get 268.7. So I get 268.7. So that is now where that's the result of the plane plus the wind, right? So if I were to draw this, I have my origin. I've got north, east, south, west. We're starting here. I need to go negative 297 in the x direction, which is this way. And I need to go positive 268 in the y direction, up that way. Now that hopefully does make sense because the plane is still going that way. The wind is pushing it down, but not by much. It's going to change it a little bit, but not a ton. Okay, so it does seem to make sense. It's going in the northwest direction at the end. Okay, so now what we have to do is now we want to find this length. How do we do that? We want to use a squared plus b squared equals c squared. So we're going to take negative 297. If you're going to keep the negative, you have to put in parentheses and square it, plus 268.7 squared. Why do I need to put the square in this thing in the parentheses? Otherwise, I'm going to get a negative number. I don't want that. So let's take the negative 297. I'm just going to take this full number because it's here in my calculator. I'm just going to take it, and I'm going to square it, and I get a negative number. I'm not going to keep that negative number. I'm going to make it positive because I know it's got to be a positive number. Okay. And I'm going to type this on the next page because I don't want to have, I want to have enough room. So when I take the square, I get 88,200. All right, and then the other one I need is 268.7. So I'm going to take, that one right here, and then I'm going to square that, and I get 72,200. Okay. Equals, and I'm going to say the speed squared. You could say c squared, but I'm trying to say that's the ground speed squared. Maybe I'll say the ground speed. The ground speed squared. So now I need to add those together. So I take 88,200 plus this. So I do that plus 88,200, and I get 164,400. Okay, so I get 160,400 equals the ground speed squared. Okay, so if I want to find what is the ground speed, then what I'm going to do is I'm going to take the square root of the answer, and I get 400.5. And I say 400.5 is about equal to the ground speed. And then I think back and say, does that seem to make sense? Well, the original plane was going 400 miles an hour. The 20 is going to slow it down a little bit, but not too much. So that seems like a reasonable answer for me to say, you know what? Yeah, 400.5 seems reasonable. Okay. So we've answered the question, what is the speed? What we haven't done is the true direction. So this might be something you have not seen before, but we will be able to do it. So what we're going to do is we need to use the ground speed x and y components. Okay. So 297 and 268. Okay, so we have the triangle, and we're going to go this way. So we know in the x direction it's negative 297, right? And the y direction is 268. Here's our right angle. We want to know the true direction, which means really we want to know what is this angle going to be, right? Well, if we find this angle, let's just kind of say this one's theta 1. If we find this one, we're going to be able to find it right here. So if we use these negative numbers, we're going to find the angle in here. If we just use the positives, we're going to find this one inside. I want this big angle, so I'm going to use these negative numbers. I can use them exactly like they are. Okay, so if I think about this in terms of this angle with respect to this angle, we have opposite and we have adjacent, right? Which one uses opposite and adjacent? Well, we have tangent. And let me just take this whole thing and move it over so it's not right in the middle of my screen. Let's move it over here. There we go. So we'd say tangent of our angle theta is going to equal the opposite, 268, divided by the adjacent, which is negative 297. Okay, so now what I have to do is get rid of tangent. If you look at your calculator, adding and subtracting are opposites, right? Multiplying and dividing are opposites. They're on top of each other. If I want to say what is the opposite of a square, it's a square root. What's the opposite of a log? It's 10 to the x. So the calculators do a lot of things with numbers and their opposites, or functions and their opposites, including sine, cosine, tangent. So if I want to get rid of tangent and I want to be left with just theta, I want to use this button called the inverse tangent. So really I want to say tangent, or theta is going to equal inverse tangent of 268 divided by negative 297. Alright, so if I do that, if I just type in second tangent 268 divided by negative 297, I am in degrees. I close my parentheses, it equals. I get negative 42.61. Okay. So theta is going to equal negative 42.61 degrees. Now, does that make sense? If I think about that one, we're making our graph. We'd say, well, negative 42 is this way, right? Negative 42 degrees. Does that seem like that's the way my plane should be going down this way, southeast? No, I don't think so, because my plane should be going probably northwest. We said we got the right number going this way with 400.5. So it seems like this is wrong, so it wants to go in the opposite direction. So we go this way. Here's our 42 degrees. So we can take 180 minus 42 degrees to get our solution. And if I take 180, not divided by, I'm going to do minus. Since it's a negative, we should do plus. This thing, we get an answer of 137 degrees. So we say 137.94. So it would be 137.94 degrees. I know this is something that really we don't have to do. What I'm really more worried about you being able to do is, from here, can you find this angle? We won't do anything quite that intense for Algebra 2. When you get to trig and physics, you might do something a little bit harder. So I know this is a long video, but here is some stuff just on direction, and direction meaning theta, magnitude meaning how fast is it going. If you were to give me this answer right now, that would be okay. Alright, so good luck on your vector problem.